stoichiometric calculations. Now, when we talked about stoichiometry, we had figured out there's a lot of information that is available from a balanced chemical equation. Now, in this video, we are going to be studying about some stoichiometric calculations. So, let's read the question. How many moles of nitrogen are needed to produce 8.2 moles of ammonia by reaction with hydrogen? Now, here, when I was in grade 11, I found it very difficult to understand as to how does one come up with a chemical reaction in the first place, because when you have such a question you need to know how to write the chemical reaction. Over time I've realized the more we practice balancing chemical equations, the more exposed we are to various compounds, and that in turn will help us figure out the balanced chemical equation or the chemical equation. Okay, so here you have been given three clues. Okay, first is you have nitrogen and hydrogen are the reactants. So there are two clues already. And here you have ammonia is the product, which means here the chemical equation is nitrogen reacts with hydrogen to give rise to ammonia. Okay, and the only reason you probably know what ammonia is if you have practiced balancing chemical equations, or maybe going through basic compounds or various examples of compounds, that will help. The reason we write nitrogen and hydrogen as N2 and H2 is because we cannot write N and H because they are not stable enough to exist as N and H. So automatically we have to write N2 and H2, and when we balance this chemical equation we will write N2 plus 3H2 gives rise to 2NH3, because here you have to balance the nitrogen first and you put the 2 here. 2 3s are 6, 3 2s are 6, and you have the balanced chemical equation. Now, from the previous video, you can notice, you remember, or if you've not watched it, do check it out. The number of moles, their basic relationship is 1 mole of nitrogen reacts with 3 moles of hydrogen to give 2 moles of ammonia. So this means 1 mole of nitrogen reacts with 3 moles of hydrogen to form 2 moles of ammonia. So then how many moles of nitrogen are required to form 8.2 moles of ammonia? That's all is the question. Okay, so we just simply the whole cross multiplication thing. So let's assume this is x, then I will get 8.2 equals to 2 into x, because 8.2 2 into x. So x would be equal to 8.2 divided by 2, which means it's equal to 4.1. So 4.1 moles of nitrogen are required to form 8.2 moles of ammonia. So here we've taken we have first figured out the equation, and then we had to balance the chemical equation, and from there we had to figure out the number of moles relation between all of these three, and 1 mole gives rise to 1 mole of nitrogen reacts to form 2 moles of ammonia. So 8.2 moles of ammonia, for it to be formed, how many moles of nitrogen is required? So basically we did a cross multiplication thing and we found out 4.1 moles of ammonia 4.1 moles of nitrogen are required to form 8.2 moles of ammonia. That's about it. It's very simple, right? Okay. In this question, they're asking us about the amount of water in grams, which means here you have to calculate the mass. So it's a mass to mass or mole to mass relationship type problem. Here, okay, so first I think the major problem or the major difficulty for us would be to figure out what the balanced chemical equation is going to be. Okay, so let's think about combustion. When we talk about combustion, it means burning, and burning takes place in the presence of a very important gas, yes, oxygen. So you have methane's formula CH4 reacts with oxygen Obviously, if you want a product, when burning takes place, it leads to the formation of carbon dioxide, and you know the other product which is formed, that is water. So this is the chemical equation. For balancing the chemical equation, or when we balance this chemical equation, you get 2O2 and you will have 2H2O. This is the reaction we had studied about in the previous video. Right. Now, methane is a gas, oxygen is a gas, carbon dioxide is also a gas, and water is also a gas. Now, in the previous video, we had studied about what their relationship of moles would be. So, moles. So, 1 mole, okay, 1 mole of methane. Since, okay, one more thing, just because we are only considering methane and water, I'm going to be talking about methane and water alone in this answer. So 1 mole of methane reacts with oxygen to form 2 moles of water. Now this also means that when we talk about its mass, 16 grams of methane forms 36 grams of water. Right. So the question here is, what is the amount of water when it's 16 grams of methane? So 16 grams of methane gives rise to 36 grams. So amount of water equals to 36 grams. That's it. We are taking the mass and mole relationship. This question could have also been had it been how many, rather 1 mole of methane when it reacts, how much is the amount of water in grams? So that will also give us the answer of 36 grams. In this question, how many moles of methane are required to produce 22 grams of carbon dioxide after combustion? So it's the same equation that we had taken in the previous question. CH4 plus 2O2 gives rise to CO2 plus H2O, which means here you have the number of moles relationship, 1 mole of methane. Again, over here we are only going to be considering methane and carbon dioxide. So 1 mole of methane gives rise to 1 mole of carbon dioxide. So the mass relationship would be CH4, the molecular mass of methane is CH4. Okay, sorry. So here we have to calculate the number of moles of methane. Okay, so here you know that 44 grams of carbon dioxide are formed from 12 plus 16 grams of methane. Then 22 grams of carbon dioxide will be formed by how many moles of methane? That is the question over here, which means we are relating mass and moles. So 44 grams of carbon dioxide is produced from 1 mole of methane. Then 22 grams of CO2 will be produced from how many moles of methane? So the number of moles of methane would be equal to 1. This is again the crisscross method. So 1 into 22 divided by 44, which is equal to 1 by 2, which is equal to 0.5 moles. So in this question, we had basically related moles and mass. So 1 mole 44 grams will give rise to, 44 grams of carbon dioxide is formed from 1 mole of methane. So then how many moles will be required to form 22 grams? So we are relating mass and mole. So these are a few basic calculations to do with stoichiometry. The questions at the end of the textbook, or rather end of this lesson, will be done in another video. That's all for now. Do check out the next video about limiting reagent.